should have handled that. But when their market risk was high and their security risk was low, it probably didn't make a lot of sense to over-invest in that admin interface. They needed to get something out fast and get people interested in it. At some point, those things crossed, right? Security risk grew, market risk decreased, and they became a target. And we saw the result of that with people breaking into this admin interface. If that was inside their internal data center, they had some other mitigating controls that could have bought them some time at least. Eventually, we all know they needed to fix the code. But if they could have limited IP access to that admin interface, or just noted, hey, all of a sudden there's a bunch of traffic on that admin interface when there used to only be one user a day logging into it, what's going on? They could have bought themselves a week or a month to get the code fix and deploy it. In a cloud model, you don't have that network topology, so you can't, network infrastructure, so you can't use those other mitigating controls. Even if they're not the eventual solution, you can't even buy yourself time with them. So in that case, you need to be able to make code fixes quickly and deploy them quickly. So code agility becomes much more important in a cloud environment because you don't have these stopgaps, things to buy yourself a little bit of time. Another example where code agility is critical is around crypto keys. So lots of people misuse crypto keys, hard code them in the code, or leave them in an easy-to-find external resource, a flat file sitting next to the application. A cloud environment only intensifies those problems. You only have more people who are likely able to access your code because it's more widely distributed, or on a host that you don't control, or in a database that's shared with another tenant. And the ability to respond to a compromise is even more important in this case because it's more likely to be compromised, and with virtualization and duplication of hosts, it's more likely that a compromise of a single key is going to compromise more than one host and do more damage to you. So again, you need to use code like the code at the bottom to keep those keys out of your code, make them harder to identify and easier to update. But you also need mechanisms for updating the key and the application as a whole more quickly, more agilely, because the impact and the risk of compromise is greater. So now what? And I think here I'm going to hand it back off to Brian.
Okay, so if there are, let's see, 3 things we're trying to leave you with. First is predict failure. First, it's fun. Second of all, we have to. We have to take the small number of data points that we've been given so far and think about how transitions to the cloud are going to cause failure. Obviously, that involves revisiting the threat model. Now, you may find that you're offered a new set of mitigations along with the cloud provider. We think there's going to be a little bubble here where cloud providers are like, hey, come on in, the water's fine, we're going to offer you security mitigation X. And when we look back on that in now, say, a decade, we're going to call that vendor lock-in. And that's not going to be very popular when it comes to reducing cost, because the more you accept from that vendor, the less agile you are, the less able you are to move from one cloud to the next. And that's going to drive up cost. So we think that eventually what people are going to end up doing is revisiting code. This isn't going to be a big deal on the flagship app. Whatever the main source of revenue in the organization is, probably that's going to get a good, thorough scouring. It's the 1,000 or 5,000 or 10,000 apps that come along after it that are going to be the interesting ones when people come back and figure out, can I look at the code? And the code, why look at the code? Because the code is the ground truth about how that application behaves. Okay, so I'll conclude with this thought. If we had an hour to talk, I might get into this in a little more depth. But what's the outcome from looking at the code? And I see three possibilities. One is you either accept the code because, hey, everything's going to be fine, or you reject the code. Rejecting the code does not make you Mr. Popular, of course, and doesn't speed this cloud gold rush. So not so good there. We've talked about why rewriting the code is not a great outcome. We can't afford to rewrite all the code. So what else do people do? Well, they try and sandbox that code. We've had sandboxes for a while. What's the problem with the sandboxes? They leak. So I think the most exciting thing going on right now is about code retrofitting. So instead of taking a piece of code and trying to put a wrapper around it, rewrite that code on the fly so that you know it has the security properties of interest to you. So I'll leave you with that thought. But if you're going to go home and do something, predict failure and look at the code. I'll leave it at that. I hope we have time for a question or two, although I know we're trying to get back on track here. Okay, everyone's going. Oh, Rich, you want to say something, or should we move on? So sure. So I'll try and keep this. I'll try and keep this brief, because this is the world that we come from. Using static analysis to look at the code and try and find weaknesses in it, vulnerabilities in it, and we do that typically. We can't ever make the code perfect. So what we've got to do is point at pieces of code that represent high risk. The way we got started thinking about this stuff is thinking about when we move to the cloud, does that change the way we need to order things? And we decided that it does. And so what we did is come up with some ways where you could tell us, hey, this code is headed for the cloud. Tell me about things that might have gone through on that first code review.
Examples like the use of an unencrypted communication channel, or logging excessively, right? Things that probably in a normal application would have been reported at a low level from the tool. Now we want to call more attention to those and give you a little advice about why you need to revisit whatever your decision you made the last time you looked at it was. That's a really big piece of this retrofitting problem. There are always going to be the special bugs that are just affecting cloud providers. You're misusing the EC2 API that you're relying on. That's not going to happen anywhere else. But a lot of it is going to be old stuff with new implications.
I think that's an important point. You're never going to make the code perfect. So given that you're going to have to ship it with some kind of problems, you're going to make value judgments about what's important to fix and what's not. When you change the execution model for that code, you have to revisit those priorities. Okay, well, should we let it rest there?
Yeah, I think so.
All right.
Thanks, everybody.
Thank you.